So let's move on to our next question. So the next question that we're going to be looking at also comes from social media. Let's just check what this question is all about, right? So we're told here that in the given diagram, so there's a diagram here. In the given diagram, DG is a diameter of the circle having radius r. DE and EF are chords so that DE is equal to EF and it is also equal to R. FD and FG are joint, right? So the idea here is two things that I want to mention on this question that are key for you to understand what you need to do. Number one, when you're doing these kinds of questions, always try to read the love letter and compare the given information against the diagram, because sometimes there's information that is appearing on the love letter but is not featured on the diagram. So you might miss on key points. So always check the opening statement all the time before you check any question and compare that with what appears on the diagram. Secondly, do not expect that your trigonometry is going to be strictly trigonometry. Sometimes the concepts of trig are linked to the concept of Euclidean geometry, right? So that you want to check what your geometry can do for you to assist you to be able to figure out questions that are in trigonometry. So do not neglect the skills that you've built when you were learning Euclidean geometry. So that is very key. It's very important for you to keep that in mind. You might need that knowledge in order to answer this question. Why am I saying this? I just saw somewhere there that they're saying there's a diameter. So at the back of my mind, I remember the theorem that has to do with the diameter that says an angle subtended by a diameter is 90 degrees. So I'm keeping that in mind in case I might need that in this question. So let's see what the story is when it comes to this, right? So we can see clearly that there in this question that there is actually an angle that is subtended by the diameter there, which is angle F. So according to our knowledge, we know that this angle must be 90 degrees before we even go anywhere. So this is like a sneaky way of telling you that there's a 90 degree there without literally putting it out there. And when you're writing that 90, you need to argue it with the reasons of geometry, right? Okay, cool. So the first question says to us that we need to write down the size of angle E in terms of theta, right? So where is angle E in terms of theta? Now, if you look there, angle E is on the circumference of the circle. It is this angle that you're sitting with there. But that whole diagram that you're seeing there, the whole thing E to F, right? All the way to G and then going all the way there to D and coming back to E is just a simple cyclic quadrilateral. So if you know your stories about cyclic quads, you know what is the relationship between opposite angles of a cyclic quad. So I'm going to simply use that relationship of opposite angles of a cyclic quad to find the angle E in terms of theta, because that's what these people are asking me to work out in this question. So if you look there, the angle E and the angle theta are opposite angles, so we know that they must add up to 180 degrees. So I'm going to say angle E plus theta is equal to 180 degrees, and the reason for this is because these are opposite angles of a cyclic quad. Very powerful for you to see that your geometry does come in here and play a big role. And then this means that our angle E will just simply be 180 degrees minus theta, and that will be the solution to the value of angle E in terms of theta, right? Always make sure that you put reasons when you're arguing using your geometry stuff. Let's go to the next question. Right. So the next question says to us there, you need to prove now that DF is equal to R times the square root of 2 plus 2 cos theta. Now, when anybody asks you to prove anything, right, I don't know what is going to happen here, but what I know is they're just asking me to calculate D for them, right, DF. So I'm going to go into the diagram and try to see where is this DF they're talking about, and does it form part of a triangle that has got a minimum of 3 things? If it does, then I know that I can be able to start working there and find the solution of whatever they're asking me. All right, so let's go back and see DF. They want DF. Now DF, I'm going to draw DF in green, is this line here, this line that you guys are looking at right now. We have found that the angle E is 180 degrees minus theta, right? And then I now need to find the side of FD, which is a member of that triangle EFD that I'm looking at there, right? Now, according to what I know, the cosine rule is going to form, it's going to be a very important resource to use in this case, because the cosine rule works with 2 sides, ED and the side EF, as well as the included angle, which is that angle that we have there, to work out the side that is opposite the angle that is included. So we are going to use the cosine rule to find the solution to this problem in triangle EFD, right? So let's isolate that triangle. That triangle EFD looks as follows, right? We've got R here, we've got R here, we've got 180 degrees minus theta as this angle that you're looking at there, right? And then this is E, and then we've got D here, and we've got F. You're looking for that side there. Right, so according to what we know as far as this is concerned, that side that you're looking for, that DF there, DF squared is equal to that side EF squared, which is R. So it's equal to R squared plus the other side there, which is R squared minus 2 times R multiplied by the cosine of the included angle, which is simply 180 degrees minus theta. So 180 degrees minus theta, right? And then if I simplify here, you will see that df squared is going to be r squared plus r squared is 2r squared minus the product of 2r and r is going to be 2r squared multiplied by the cosine of 180 degrees minus theta. Very important for you to keep that in mind. Now, someone is probably asking, well, where are you getting all this information? On the information sheet, the formula sheet, this is a grade 11 concept. So some of the things that we do here, we hope that you guys understand and remember them from grade 11. Someone was asking on Facebook, sometimes the concept that you guys are working on are a bit difficult for me to follow because I'm lacking the basics. If you watch the show before this one, the Tenfold prep show, it gives you a lot of background knowledge that helps build you and prepare you nicely for what we are doing here on this particular show. In addition, if you have the app, you can go back to grade 10 and grade 11 swag and check the revision on that. And then when you come and see what we are doing here, you'll be able to follow suit without any challenges. Like now I'm using the cosine rule, which comes straight from grade 11. I'm picking it from the formula sheet and using it because I've got two sides. When you've got two sides and an included angle, you can use the cosine rule to work out the value of the length of the third side to that particular triangle. So let's continue now. So this looks tempting. Please be careful of this pitfall prevention. Don't subtract 2r squared and 2r squared and call that 0. That will actually be a big mistake. Please, please, please make sure that you don't do that, right? Those are not like terms, so I'm just simply going to ignore them. I'm going to continue and try to simplify here and say I've got 2r squared minus 2r squared multiplied by the cosine of 180. Now that, beautiful people, is going to be negative cos of theta, right? Because this is the second quad. 180 minus is the second quad. You see, reduction formulas are playing a big role. This is the problem with trig. Any part of trig can feature anywhere in any question. You could be doing 2D and 3D and the double angle sneaks in, or equations can also sneak in. So you've got to be competitive and know how to work with all those concepts. So cos of 180 minus is as good as negative cos theta because that is actually from the second quad. Now, if I simplify this, I'm going to get 2r squared. Now, negative here multiplied by the negative is going to give us positive 2r squared multiplied by the cosine of theta. We do have a common factor here, which is that r squared. I'm going to take it out as a common factor. I'm going to have r squared into 2 plus 2 multiplied by the cosine of theta. Remember, we are dealing with df squared, and we are looking for df. So therefore, df will just simply be the square root of what you're looking at, because you just have to take the square root on the left and take the square root on the right hand side. Remember, always put plus and minus in front of the square root, but I'm dealing with length, and length is never negative. That is why we're only going to take the positive version of that square root. R escapes the square root as r, and then you're left in the square root of what is left inside there, which is 2 plus 2 cosine of theta, which is what the examiner wanted us to actually find in this question. That's what the question was all about, finding the length of df. So df, there it is. df is indeed r times the square root of 2 plus 2 cos theta. Very powerful, right? The last part of this question, let's see the last part of this question. They say now prove that without any further, complications, prove that 2 sine squared theta equals to 1 plus the cosine of theta. Now this one is tricky. We want you to prove 2 sine squared theta equals to 1 plus cos theta. Let's try and go back to the diagram and see what we know so far. Let's see what we can actually see about the diagram and what is happening here. Right. So allow me to remove all that I know so far. What do we know? Well, we know that df is something. Let's write the length of df. We know that this length df is as good as r times the square root of 2 plus 2 cosine of theta. That's what we know about the length of that. Now, if you look at triangle DFG, that triangle DFG there, that triangle DFG, we know that there's an angle G there, which is your theta. We know that DG is R and R, which is 2R, and now we are looking at that side DF there, and we are required to find the sine of theta there. So I might come here and try to forge the sine of that angle G that you're looking at there and build a ratio that is going to look as follows. So I'm going to say the sine of theta, according to your trig ratios that you learned in grade 10, is opposite side divided by the hypotenuse. So the side that is opposite is that side that you're looking at there, which is the side DF. And that needs to be divided by the hypotenuse of this triangle, which is that DG that you're looking at, which is R and R, which gives you the length 2R. Right. Now, if I cross multiply here, I'm going to sit with this over 1, and 2R multiplied by the sine is going to be 2R multiplied by the sine of theta equals to 1 multiplied by df is simply going to give us a length of df. Right. Now, I'm looking for sine squared. So I'm going to replace df with the length that we found in the previous question. Remember the following: nobody asks you anything for fun. When you ask you number 1, more often than not, the idea is we are helping you to use number 1 to figure out the solution for number 2. And number 1 and number 2 are also going to play a role in helping you to find the answer for number 3. So when you get stuck, always ask yourself, why were these people asking me question 1 and question 2? What was the purpose of all that? The idea here is in geometry and trigonometry, particularly this part, we are guiding you. Do this. Now do this, now do this. So as you keep moving on, what you found becomes very useful to help you to find what is following. Right. So now df has been found. So I'm going to write on top of my drawing. Please excuse me. I'll write 2r sine of theta equals to that df, which is r times the square root of 2 plus 2 cos of theta. Right. So if you look there, r is common on both sides. So I can simply remove it by squaring. Before I even square, I can actually divide on both sides by r. So when I divide both sides by r, I'm going to be left with 2 sine of theta equals to just the square root of 2 plus 2 cos theta. And if you square on both sides because you want to eliminate the square root, when I square on both sides, if I square on both sides to eliminate the square root, you simply end up with 4 sine squared theta. It's just those two things inside there will be freed there. They'll get out of the square root because the square will kill the square root. We're sitting now with 2 plus 2 cos theta. If you divide everything by 2, you then end up with that 2 sine squared theta is 1 plus 1 cosine of theta, which is exactly what the examiner wanted us to prove in that last question. Right. So I hope you can see what you guys need to do. Always keep in mind, whatever you have done is crucial. That's the number 1 thing you need to keep in mind. Number 1 is important for number 2. Number 1 and number 2 will help you to find number 3. So we are leading you on, so you don't have an excuse not to ace these exams when you meet them.